All right, this is our last day of notes for our astronomy unit. Today we're going to look at the relationship between the moon and the Earth. So let's talk about where the moon came from. At one time, it was actually part of the Earth. And then when the solar system was forming in the early days, there was a lot of motion, a lot of things bouncing around. An asteroid or something about the size of Mars collided with Earth, as you can see in the first image right here, knocking off a chunk that was ejected into the space surrounding Earth. And similar to the nebular theory, all of those particles started orbiting the Earth, and through the process of accretion, eventually clumped together to form the moon. And today the moon is still orbiting around the Earth. We call this the giant impact hypothesis. So again, not Mars, but something the size of Mars struck Earth during the formation of the solar system, caused that debris to be ejected, begin orbiting space, and then clump together to form the moon. And it's the same process of accretion that formed our planets. All right, so while the Earth is revolving around the sun, the moon is revolving around the Earth. It also orbits in an elliptical path, just like the Earth and other planets. And so part of its orbit, it's closer to the Earth. That is called perigee, similar to perihelion when the Earth is close to the sun. And then apogee is the point when the moon is furthest from the Earth. Another interesting thing, have you ever noticed how the same side of the moon always faces the Earth? The reason is because the moon's period of rotation, which is the amount of time it takes it to rotate on its axis, is 27 1/3 days, and its revolution around Earth is 27 1/3 day. So the same side of the moon always faces the Earth. When we look up at the night sky, depending on what part of the month it is, we see different phases. And what you're seeing is sunlight that is being reflected from the moon's surface. So it starts off with a new moon, which we can't see any of it at all. Then we see a waxing crescent. Waxing means it's getting larger. First quarter moon, waxing gibbous, and then full moon. After the full moon, the moon starts getting smaller again. The term we use for that is waning. So we have waning gibbous, third quarter, and waning crescent. All right, another thing that the moon can affect on Earth is something called a solar eclipse. When the moon moves in the path of the sun during the daytime, it can block sunlight from reaching certain parts of the Earth. This is called a solar eclipse. So the moon passes directly between the sun and the Earth. If it's a total eclipse, it'll actually get dark during the day. Our last eclipse was last August in 2017. From this area, it wasn't a total eclipse, but you could see the lights dimming. Because of that, the moon casts a shadow on the Earth. In the western part of the state, they could actually see the total eclipse where it got much darker. This type of eclipse is visible during the day. Now, a lunar eclipse is when the Earth blocks the sunlight from reaching the moon. So this would be visible at night, and it's called a lunar eclipse. You could see the path of the Earth and the shadow as the shadow moves across the moon, as you can see in that image there. All right, the last way that the moon affects the Earth is by creating tides. The moon has gravity, just like every other celestial body, and the gravity pulls on the ocean, which creates a bulge, both on the side facing the moon and the side facing away. The reason there's a bulge on the side facing away is due to centrifugal forces. Have you ever been riding in a car and you go around a curve and your body's kind of thrown to the outside of the car? It's a similar idea that the ocean kind of bulges as it's away from the moon. All right, so what happens on the side facing the moon and the side facing away, there are two high tides, and the two opposite sides would be low tides. So as the Earth rotates on its axis, it moves through each of those tides. So during high tides at the shoreline, the waves are going to come in a little bit further. High tides, the waves are pulled a little bit further out. So here's another animation where you can see how the Earth is rotating through each of those tides. Now, another effect, when the sun and moon are lined up, whether it's a full moon or new moon, you can see those tidal bulges are even higher than normal. That is called a spring tide. When the moon and the sun are at 90 degrees, so that would be first quarter and third quarter, there's not much difference between high and low tide. That is called a neap tide. And that is it.